we'll get going now. So we're quiet and introduce to you Dmitri from loveholidays. Thank you.
Hello everyone. Can you hear me well?
Yeah.
Okay, good stuff. So today I'm going to talk about GitOps and running it in production. To kick it off, I would like to ask you a question. Do you really know what is running your production right now? I mean, really running, not just what you assume is there. Right now, I can tell you exactly what's in my production without actually accessing it. This is done thankfully to the GitOps. Would you ask me the same question a year back? I'd have to delete all my VMs, tear down applications, build them from scratch, redeploy, and I'll be sure what's deployed. But over time, my confidence will drift. I believe that all ways of doing CI/CD are no longer suitable for the cloud-native era, and I do encourage you to move on. I'm Dmitri Lerko. I'm looking after DevOps at a light travel agency called loveholidays. You are welcome to connect and ask questions on LinkedIn. I occasionally talk about GCP, DevOps, Kubernetes at deploy.live. I will be aiming to add some more GitOps information there as well, sure, after this session. I'm certified in GCP, Kubernetes, maintenance. Just to cut straight to the chase what GitOps actually is, it's really important to make sure we're all on the same page. Fundamentally, it's a change away from push to pull in your continuous delivery pipelines. It's not very simple, it's truly subtle. What the impact it has on the way you run things is profound. Imagine that in the past, you had to tell your system what is there for them to run, so you have to deploy it to your environment, Kubernetes, you tell it. With GitOps, your environment asks you what is there for us to run. They check it out and they make sure it's running. With GitOps, you store a declarative desired state of your environment in the source control, and it's a job to make sure that it continuously syncs it with your environment. Therefore, there is never a drift. Given this, making changes with the GitOps are as follows. You go to your repo, you commit a code change, you wait a couple of minutes, and it's eventually consistent, so your change gets propagated. If somebody comes in and deletes stuff from your environment, GitOps will take care of that, bring it back in. So unless it's in the source code, it's not going to be recorded. And if it's deleted from the environment, it's going to be still brought back to the state that is described inside the source control. Don't take my word for it. The Kelsey Hightower thinks it's awesome, so you can always trust this dude. I also have to confess, this entire presentation is a giant lie. The lie is hidden in the title. I say that it's 1 year of GitOps in production, and I was meant to do this talk in September. So what you're going to see is an early preview of 10 months with GitOps in production. The rest of the presentation is going to be a lot more factual. Who is running Jenkins here? Okay, that's a good half. And who is running Kubernetes in production? So same half. Is it the same people? Those who run Kubernetes Jenkins in production, raise their hands. Okay, no, that's actually two separate thoughts. And I've already seen a few hands for the GitOps, so there have been about 5 hands raising up earlier. So who's running GitOps in production? Okay, that's unfair because you work with me. Very last question. Who does really know what's running your production right now? Really now. Who's confident? Good man. Okay, good man. Let's move on. So I believe it's important to give a bit of backstory. How did we decide to go to GitOps and what brought us there? We had a fairly standard setup. We've been running physical servers on collocation environment. We've been hosting KVM VMs. We run Jenkins singular. One Jenkins to rule it all for all our continuous integration of delivery needs and complete monster. And lastly, it was using Ansible and some kube control to perform deployments into our environment. If you look at what was making up our continuous integration, it's very simple. Me as a developer committing code to the Git, Jenkins is following this repo, gets the changes, builds them, and produces artifact in the repository. But this was only true for the main branches. It's not because I can't automate the feature branches, it's because we didn't have enough servers to run as many builds as our developers delivered. Therefore, I had to put the tax on them of cognitive load, or they need to decide whether the candidate they've just pushed needs to be built or not. Not a great place to be. I absolutely hated that. Continuous delivery with Jenkins, also named as a CIOps, everything is driven from your CI tool, is also super simple. You have developer going to Jenkins, spending about 5 minutes to find the right tab, job, version number to deploy, pressing the button, and then your Ansible or kube control takes care of pushing it out into your Kubernetes cluster or maybe VM, whichever you run. It actually doesn't sound too bad, so why would you move? So we've been, I personally run that monster of Jenkins for 2 years and have quite a lot of insight. So the next 4 slides are jam-packed with information, pay 100% attention. 1. I lied. It isn't jam-packed with information. I'll try it again in 2 minutes time. What we have with Jenkins can be described as a snowflake ops, because if you are an external observer to our CI/CD platform a year ago, and you watch us use it for a day, you'll think our singular goal was to increase entropy, to make sure nothing is the same in randomness. Just try. Your pipelines, build jobs, nothing is alike. Even UI is inconsistent because there it uses the blue ocean, there it uses Ruby pipelines, there it uses the old promotion plugin. Nightmare. So now, that's going to be 4 important slides. Number 1. Number 2. Number 3. And number 4. I thought it was surprising that I wanted to move away, right? That's the one monster to just rule the world. I actually have a real insights out of this. Do not do free-fall plugin installs of Jenkins. You'll regret. That's just nightmare. And we only had one physical machine to do this build, at least to manage the Jenkins master. So any upgrades for your plugins or any upgrades for your security patches of the Jenkins itself is a nightmare. We have to back it up, we have to do it out of hours, and we always find epic and dreadful at the same time. But it's not all that gloomy, so about a year ago, we finally proved the case that we as a company need to move to the cloud, and GCP was the cloud of choice to go. So what we had to do now is to make sure that we do not repeat mistakes of the past in the cloud native era. We set ourselves a bunch of goals to make sure that things will be cleaner and neater now. First of all, I wanted to have a full audit trail for my CI/CD, especially the CD business. In the past, with the Jenkins, you have to open Jenkins, find the tab, find the pipeline, find the job, find the particular build, and then put it next to a hash and a name to know what has happened deployment-wise some time ago. Jenkins down, well, your trouble. Jenkins disappeared, your trouble. So there is no easy way for me to tell what happened. So I want to have this database, and Git is an excellent database. I want to have everything as a code. It's simple as that. I want my continuous integration and my continuous delivery deployment scripts to be source control first, fully reproducible, built from scratch in any new place I want to have them. I don't want to put any restrictions on my developers. They should not really think about whether this commit is one to build or next one is a better. I want to build every single commit. And I also want to remove limitations for the deployment. In a physical environment, to perform a deployment, it's always the trade-off against your capacity. You have to take a part of capacity out, update the versions, put it back in. If you are trying to do 2 deployments at the same time against the same service, you're likely to take it down, or you need to build a really good defense mechanisms. Until we built those, we had a lot of outages. So I just would like to take completely away from the picture of my developers and QAs and their deployments. They should be able to deploy when the feature is ready. That should not have criteria to think about. I don't want to have any configuration drift, so I want to ensure that whatever I have set as a desired state within my repo, it's exactly what's in my environment, nothing else. And lastly, the job of continuous integration is to produce deployable artifacts. The job of continuous delivery is to make sure they're running in the environment. And for a really long time, it's been okay to allow you continuous delivery, to have unrestricted access to a lot of environments to perform this action. It's only one way to achieve it, but it's definitely not the best. I would like to take this power away from my continuous delivery. So given all those goals, and then thinking about what GitOps can provide you with, that's a perfect fit. It just gives you all the requirements that I understand for myself for our platform maturity. If you think that GitOps is that scary tool that you don't want to add to your stack and you already have gazillion tools and they push it even more, you think differently. If I had only 5 minutes to implement GitOps, I'll do something like that. I have a forever running while loop that pulls from my source code and applies that to a cluster. That's GitOps. I do not recommend running this in production. Well, if you're very adventurous, maybe. That would be. So instead, we went with slightly bit better tool. We forced the guys who originally coined the term GitOps, created a tool called Flux. They do a lot of good stuff around open source, so I had no reason not to trust their solution and give it a go. We tried it, works pretty well. Once we decided what is our CD going to be, we had to define the CI. And luckily for us, end of July last year, Google have rebranded Container Builder as a Google Cloud Build. It's a very minimalistic CI/CD platform, which is super well tightly integrated with the GitHub. So it's a couple of clicks and your repos are linked into the Google Cloud Build and builds into the back. Minimalistic side also comes to the way how you define the build steps. Each build step is a Docker image, and they give you a bunch of them, like 10, Gradle, Maven, NPM, G-Cloud, and a few others to do the more standard stuff. But if you'd like to extend that, you can always write your own Docker image and use that as part of the build, or you can use community builders. It has no real limitation of how many parallel builds you can do. There are about 10 different projects, but if you have multiple projects, that limit becomes so high that for nothing but the biggest organization, it's not much of a problem. Or maybe you can really, really slow build. And lastly, it's declarative and it's code source code first. That's how it looks like. Here you have a build that does Java Gradle build. Does a bunch of stuff using Gradle image. And then we're running a custom step, a custom builder that we wrote called GitOps. And I'm going to talk about that in a second. And then this is just going to produce an image of your advanced app and start on our registry. Each repo in application has the copy of very similar stuff to perform the build steps, and owners of one of those applications manage that. So I no longer manage Jenkins, there is no such thing. It's just small little snippets of declarative build pipelines scattered around application repositories. So in theory, continuous integration with a Google Cloud build is no different, except that you swap the word Jenkins for the Google Cloud build, and now you do it for every single commit, whether it's a feature branch or whether it's a master branch. In practice, it is slightly different, and we added a custom step called GitOps. So once you build artifact, test it, and build the code, test it, and create an artifact, we're running the very last step of the GitOps, which talks with a Flux Git repo. So a little bit more on that. Unfortunately, it's not an open source build step, but I'm giving you a recipe and you can figure it yourself very easy. You need three tools, obviously Git. Next tool is a hub, which is a GitOps, a high-level CLI tool that allows you to create PRs, to do reviews, and also use YQ, which is JQ equivalent but for YAML. Using Git, you checking out the GitOps repo, you creating a branch, you updating the version of the image that you just built, which was your best one. With a new version v2, you commit those changes, you push it into the branch, and using Hub, you're creating a PR. There are very tiny URLs here at the bottom, but I'll try to share the dev with you so you can find those more easily. That's pretty simple. So now when we go into the cloud, to the continuous delivery aspect of it, I'm a developer, and now I have a PR bit automatically created by my build. I look at this PR, I review, I approve it, and I merge it in. At that very time, v2 of my best app is being merged into the main branch of my Flux Git repo. And what I have is an application running on my cluster called Flux GitOps. It continuously polls my Git repo for any changes. It finds that I push the v2 version of the app, and it makes sure that my cluster is in sync with whatever is in my source control. Because source control is a source of truth, and you the singular aim of Flux to make sure that your cluster looks exactly as described in your Git repo. So going back to the benefits, they're huge, but there could be skeptics in the room that need a bit more convincing. So GitOps gives you best practices. Like really strict teacher, it cannot disallow you to be silly. You can still mess up stuff. I can have view control and apply everything to my production. But what GitOps does, it lets me do it, it watches me do it, and it changes it back to actually what it's meant to be. So it looks at the source code and applies the change back to production. Next thing I do cube control edit on my production config map. GitOps will let me do it, and 2 minutes later it's fixed back to what's defined in the source control. Even if you're the most stubborn person, it only takes a few tries to start doing that. And you know, the way to change things is to go to the repo and update it there. And it's also such a natural way for developers to perform deployments. You don't look up for a new tool, you just change the code. And hence I believe it's super developer friendly. These days, when there is just the community when you're pushing in new tools and developers saying that this next tool is going to solve all your problems. And they want to keep increasing that tool stack, so you're going to be the best developer out there. I think there are way too many tools already, and we should focus on those that work. And by using GitOps, you can do a huge favor to developers by removing continuous delivery application from the stack. Now they just use GitHub, GitLab, or Bitbucket to perform changes, which is a lot more natural flow. Lastly, I don't take some minutes to like GitOps, so I wanted to want to give it a go and be overly skeptical. But for those who are skeptical, let me tell you a story. On cold, sunny, wintry day of December 28th, it was about 12 o'clock. I've been working my favorite tool, GitOps by Flux. And I was updating the configuration for the stage. That was going really well. That also shows how much we love GitOps. We love GitOps so much that we managed to use GitOps. So it's a bit of inception there. And I made my change, and I applied it, and I cut the corner. I did the silly thing that I should not be doing. I did kube control apply it. And that in itself would be okay because I was a source control issue. There was a slight, tiny issue with this. I was not connected to my staging cluster, I was connected to my production cluster instead. So what happens when you apply staging GitOps configuration to your production cluster? You know it? You've just created a monster. You created a self-replicating mechanism that has one purpose in life, to make sure that your production environment looks exactly as you want to stage it. not the best thing to do. And where you have a lot of configuration drift, you will suffer even more. So initially I thought it's some fucking good developer of mine staging configuration in prod, and I was trying to figure out who, and that was me. I've applied correct production change to the GitOps once I realized the mistake, and it became a good citizen again, and it's worked really hard to make sure that my production look exactly as I wanted to prepare my Git environment. So, although it was about 18 minutes of the greatest state, but much more painfully personally is that I had to pay a tribute to our dead by sugar butler with those donuts, which is a fair price for a mess up like that. Another issue that you might experience with Flux and GitOps is broken YAML manifests. If you do stuff that is just impossible for YAML to comprehend, you're going to break. And that's the same with kube control apply, or if you're using the CI tool that manually tries to push your stuff into the cluster. That stuff all going to break if you're doing broken YAML manifest. But there is a slight difference with the GitOps when using Flux. It's going to get upset, but it's going to just complain about it in blogs. So unless you monitor blogs, you will never know that it's broken. So just be aware that you might break your changes. So we at loveholidays really love GitOps, and it works super well for the last 10 months. In fact, we performed 11,190 deployments since September, which is not an insignificant number, and I would like to do a lot more with it.
Actually, a couple of comments.
It should have.
I think fails.
You can perform, actually, you can deploy multiple commits per deployment and changing one image, so it probably doesn't match the number of commits because it's higher. Even more interesting, me as a person who works in my clusters and my environments all the time, I spend most of my day doing something and tweaking things around. I find myself using GitHub a lot more often than I use kube control, because GitHub is just more natural to comprehend a large set of information about my running system. And I trust GitOps so much that I no longer need to use kube control, which to me is something unbelievable. If you asked me a year ago, would they give up kube control? Now it's the code still out there. Not anymore. But it's only the beginning of journey, and there are a few things to do. So what we're considering doing going forward is to embrace continuous deployment, canary deployments. For that we need Istio, so it's coming. The Weaveworks guys have actually got a tool for managing GitOps canary deployments. It's called Flagger. I haven't tried it yet, but I think it's worth mentioning. They also got yet another tool. I'm really not sponsored by them. Called Kubernetes. And the purpose of this tool is to let you know what is different between your source code and your running cluster. If you take this knowledge and you do kube control delete, you have an ultimate system that removes all the garbage or all bad developers' code from your cluster. So it's something we would like to try. So if you liked what we talked about and you would like to give GitOps a try, here is the URL. It's fairly simple. And there are some articles that it works about how they've been running it. But it's not the only implementation of GitOps. Another two notable entrants are RSE and Razy. Razy is open source by IBM. Haven't tried them, but you're welcome to go. If you did try, let me know. If you enjoy Kubernetes, GitOps, and you would like to help me out to build my platform at loveholidays, we're hiring. Any questions?
Got time for a couple of questions. Anyone want to shout one out? Yep, go ahead.
I just want to ask, how do you identify the environments that you have? I mean, you say that you were connected on the wrong environment. Is there a knowledge in the environment that, oh, I am the production one, so you can double check?
Yes, so you're on both. The question is there a knowledge by environment, what environment it is? And the answer is yes. By deploying Flux to environments, you tell it what it is. Therefore, you can monitor multiple repos, you can monitor multiple branches, you can then have multiple fluxes running on the same cluster, because you may want to separate applications type from, let's say, the system tooling, and that to be joined on a cluster from the two different directions.
Okay, any other questions for Dmitri? Progress?
I was wondering, your CI/CD pipeline, why do you integrate automated functional tests, if any, especially kinds of that are not before you build, but more like end-to-end tests.
Yep. It's going in the shameful direction. We're still using Jenkins. And the job of this Jenkins is actually pretty cool. We have a development project which allows us to create 50 or 60 replicas of production sliced around. And we're running tests against that. So we have a mechanism where we can cherry pick versions to deploy and then fall back on the latest version of the rest of the components and run tests. And developer explorer for testing against that. So that works really well.
Okay, thank you very much, Dmitri. Next is, I've got one more question.
How do you mitigate the risk of security vulnerabilities within the cluster?
I should follow up. True cluster in what sense?
In terms of, say, you've got libraries for
So it's a question completely outside of what we do, right? So it's just an external question. Do OWSP testing? I think that's the best answer. But GitOps is no different. It suffers the same way.
So yeah, Dmitri had to do that talk without his speaker notes. We spent a few minutes faffing around trying to get it to work. I know it's a pretty horrible feeling. It's like you've got a parachute and jumping out of an aeroplane doing that. So I think an extra special big hand for Dmitri for speaking.